Hey YouTube, today I'll share how I'm selling my 3D prints locally, and later in the video I will use Fusion 360 to create another useful part for an exhaust vent, and I'll have it printed by the end of the video. Hey YouTube, welcome back to the channel. If it's your first time here, my name is Will and I'm a 65-year-old man who has started using Fusion 360 to help with my 3D printing business to sell useful parts on Amazon as print on demand. So welcome to the channel. So if you're new here, you probably don't know I've been in research and development over the last 10 months learning how to create useful parts that I can sell either on Amazon or just to local individual businesses in my area. And lately, that's exactly what's been going on. I've been working with several companies to do different parts, and they've pretty much develop them and send them to me to be printed, which has kind of worked out really nice. I don't have to do a lot of fusion to get them set. The companies I work with are custom shops. So, and in your area, I'm sure there are custom shops of some type there too. I am working with a custom cabinet company that also makes custom furniture, and they design parts and furniture one-off. And what I mean is that they make everything they make is unique. They don't make the same cabinet over and over. They're not like a IKEA or some type of company like that. This particular company usually has pretty high-end clients, and cabinets can run for the whole home anywhere from $400,000 to $850,000 just for the cabinets. But in the last 10 months, I've really pushed myself to learn Fusion so I can create my own parts, which I really enjoy doing. The point from the sketch to the running it on Fusion and then having it printed out at the same day is pretty remarkable. Sort of a Star Trek-y thing. I've also found that 3D printing and Fusion 360 really kind of go in hand. Now, you don't have to use Fusion. You could use Tinkercad or some other type, but after you get over the few hurdles that you have to really cross over in Fusion, it becomes easier, and every time you use it, you get more proficient at it. But after working for the last 10 months to try to do the research and development, and now I'm trying to promote my business in the last month or two, the phone calls have already started coming. I have a conversion van company that is interested in me coming in and working with them, trying to get some specialized parts for handicap and elderly senior adults, which I think will probably work out later down the road than it will right now. But you have to build those relationships in with these companies so they know that you're there for them when they need you. Other places that you could really contact is just about anything that says custom in their name. Custom bicycle shop, custom cabinets, custom conversion vans, custom motorcycles, just about anything that they're going to need special developed parts to do. And what I mean is, like, let me show you this one. This one came in from the cabinet company, and I'm not going to tell you what it does, but this is what they needed, and they needed 20 of them. So we're going to print those off for them. But they call it a hat. It has 4 little points on the bottom, and of course with that ledge that it has all the way around it, we're going to have to support it. And luckily, by the way I've got it oriented, this is the only part that gets seen, and it really doesn't get seen because it's in the back of a cabinet. So it's just a part that they need to seal the cabinet, I think. Yeah. So now for them to go and find a company that can create an injection mold or some type of mold that can accommodate to make that type of part would have took them months to do and cost thousands of dollars to do. And that's where you have to kind of bring up to them, these companies, that you can do it cheaper and quicker and saving them so much time and money. Ed over there sent me the file, and I took it to him the next day. He wasn't sure if it was going to work or not, but it looked like it would. He had, sketched it up in Fusion and sent it over, and everybody seems to be happy. So as you can see, it really is going to cost me $1.20 to make, and it takes 2 hours and 27 minutes to make one. So I could throw 4 of them on a bed, get them all done within 3.5 hours, times 10 printers, which would give me 40 units right off the bat within 4 hours. So there's not a lot of cost as far as time other than to set it up and do the post cleanup, which really wasn't that bad. The tree supports just broke right off, and the back edges, it didn't really need very much post cleanup. And even if I didn't do the cleanup, it wouldn't make that big a difference. Like I said, it's in the back of the cabinet, and the parts that have the supports are actually facing into the cabinet, so they can't be seen. But that's where you should start looking, just in custom cabinets, custom whatever, in your area, and see if you can, create relationships with them doing that sort of thing. Another thing I had done with the cabinet company is sit down with their design team and explain how 3D printing works and the fundamentals and limitations of 3D printing, how to orient parts, what type of parts can be printed, what cannot be printed. The owner of the company is ready to go ahead and start doing end panels for some of the cabinets that are custom. Some rounded edges with fluting and a bunch of other stuff that goes on for these type of cabinets that are so high end. They'll be able to print them and then screw them to the end of the cabinet skeleton from the inside and send that to prep and paint, and then have it ready to be installed. Unlike wood, it wouldn't swell and contract as much, and in bathrooms that really can become a problem, especially with custom wooding cabinetry like that. So all in all, that's what I've been doing outside of the office here. I've also noticed an uptick in my emails and phone calls about having 3D printing done. So it's just a matter of putting yourself out there and just waiting and keeping developing your craft in order to be efficient at it. So after 10 months, it looks like my phone is finally starting to ring and we're starting to do some sales. And like I said, I've been more into the research and development and just getting ready for this point, more than I have just jumped out and started selling. We sold at some of the local markets, on the weekends, just to see how things would go, and they do okay. You can make a little extra money out there, and I suggest that you do it. So anyway, just a little update on my Traxsaw track holder. We've changed the design so much now that we might as well just go get a patent on the top part of it because of the mechanism. So it looks like it's going to take a little longer for that to get to market. I could actually just send it out, but somebody would just take it anyway. And if I didn't do a patent on it, then somebody would probably patent it and then sue me for using it. And that's how the world works. So you can copyright an STL file, but anything mechanism or any type of mechanical design, you have to get a patent. And the copyright lawyer told me that might be the route I need to go on this particular one. What else? I printed TPU last video before last, and I failed to mention so much stuff, and I apologize. I'm so new at this. It's so hard to get things in. One gentleman didn't even know what I was talking about with an AMS system, and I guess most of us know what it is, and I assume and that's what the deal is, that you already know most of it, because I would imagine you guys know more about this than I do. I've just got a bunch of nerve where I can get on video and talk about what I'm doing. But I didn't tell you the troubles I had trying to get it started. I told you I had a few bad prints and stuff. And just to give you, for instance, I had the TPU in the dryer, in the AMS system, drying for 8 hours. But once it was done and I had let it cool off a little bit, it was still like a spaghetti noodle. And when I ordered TPU, I assumed that I could run it through my AMS system, but I found out very quickly that I couldn't. Bamboo does put out a TPU that supposedly can go through their AMS system, but I haven't even tried that one. I should have just bought it from them in the beginning and made this whole process easier. And what I mean is, since I found out I couldn't, I'd already been set up to run it on this particular printer, so I had to pull it out and find another spool holder that would hold it, and I couldn't find one anywhere without having to print one off, which would have took hours. So using my ingenuity, I used this, and man, did it work great. it just fed off like it was nothing. You know, if something's not going right, you can figure out a way to get it done. I even had to pull the PTFE tube off and then feed in the TPU and then push it into the extruder and then push the tube back in just to get it fed in. It was such a limp little thing, but once it was in, it was okay. I had it on a regular spool holder, which didn't have any ball bearings or didn't turn very easy. And when it pulled it would stretch the TPU, and it would give me thinner lines at the beginning on the plates. But once I went to the paint roller as a way of rolling it off, it rolled off real smooth, and it gave me steady, thick lines all the way through it. So TPU is a little difficult to get started, but once it's started and set up, it works okay. So I'm still wearing the shoes occasionally when I remember to put them on. So if you made it this far, like I said, I hate asking, but if you would like and subscribe, it really helps my channel to grow. I feel like I'm begging sometimes for a like, but and I'm so new at this, that's practically what I have to do. But we're going to move into another Fusion 360 video. I understand if you cut away from here, it can be boring sometimes, but sometimes it can be kind of entertaining because I tend to screw up a lot anyway. And I appreciate everyone commenting and letting me know shorter ways to find a solution. So if you see something that I'm doing, or maybe I'm not doing it right, or whatever the case, please comment. I won't know unless you tell me, and I think you guys got more experience at this than I do. I'm just trying to document the process of me getting to a point in my life where I can actually quit my day job and have a couple of revenue streams coming in so we can get to retirement. So what we're doing today is an exhaust vent that I've got for my dryer. It's nothing but a hole now. My wife's just sure that something's going to crawl up in there and make a nest, and she's going to have a fire in the house. So we'll get that fixed for her. I know it's a little redundant to come over here and draw this out for you, but it helps you to visualize what I'm going to be doing in Fusion. So I'm just going to create the base of the dryer vent mount. It's going to be 150 millimeters by 150 millimeters and approximately 5 millimeters thick. Here I'm finding the center, which is going to be the center of the vent. This hole is actually going to need an inner and outer circle in order to create a wall in Fusion so we can extrude it up to 35 millimeters past the top of the base. So our measurements are again 150 by 150. The holes are 7 millimeters in diameter, and we're offsetting them from the corners 19 to 20 millimeters. The wall for the vent hose holder is going to be 5 millimeters. Okay, since we've got our sketch, let's go ahead and get into Fusion. On your first page here, you're going to start a new sketch, and that'll put us on our palette. So we'll make this quick and easy for you. First thing we're going to do is we're going to work up in here on the toolbar in the solids and in the sketches. So all your buttons will be located in this area here. So right now we're going to create a sketch, and what that does is go ahead and we're going to start drawing onto our palette the shapes that we want to build upon. So go ahead and click here. It's going to ask us which plane we want to build on. I like to use the flat one there. And there we go. And then we're going to start with a rectangle, which is right up in the top left. And you'll click on it and you'll set your first point. And then when you pull from that, you'll get two fields that you can type in your measurements for. So I want to go ahead and type in 150, and that's going to give me my height. And then if I hit the tab button, that sends you back and forth from each field so you can put in your numbers. So here's another 150, and then after that we're just going to hit enter. Let me pull this out a little bit. There we go. The next thing is our hole in the middle, which is 90 millimeters in diameter. So we're going to go ahead and reach up onto the toolbar and grab your circle. We'll set that right in the center and just hit your mouse button one time, and if you pull out, you can see that it's going to allow you to put in the numbers in. So we're going to put in just 90, and that gives us our hole for the dryer vent. So we have pretty much the body and where the hole is going to go. Now we need to build the vent itself, which is going to extrude up through the top, and it needs to be 35. But we're going to make the body 5 millimeters, so we're going to have to add that 5 into the 35 to make it 40 millimeters high when we extrude that. But in order to extrude that, it needs to know what the thickness of the wall is going to be. So what we're going to have to do is do an offset, and that's an easy thing to do. We're just going to click on the circle and then hit the O button for offset. That's your shortcut key for it, and it just automatically pops up your field to ask you what measurement you want. You can actually grab it by the arrow. You could pull it in or you could pull it out. You see, if you pull it in, it's going to be a negative number, and if you pull it outside the line, it's going to be a positive number. So in this case, we want it to be over the body and not over the hole. We want to keep our 90 millimeters diameter there. So we're going to type in just 5, which will put us in the positive side, and hit enter. And so now we have the wall of the vent itself. So we have the body, which will go up against the brick, and then the hole, and then the wall of the hole. So now I'm going to set a reference point for the holes to hold the body to the wall. That's where the screw holes are going to be. And what I'm going to do is set a reference point at, I think I had said 19 millimeters, but it's probably easier just to do it at 20. So I'm going to go in and just go to the 20 millimeters. And I'm done with that. I can hit escape, and that gets rid of the tool. Anytime you want to reach up and grab something, you can always hit escape, and that puts the tool back up on the bar for you. So now we're ready for extrusion. So what we're going to do is take the body. We'll go ahead and go to solid and hit extrude, and then we'll pick the body and we'll set its thickness at 5 millimeters. So you can see that now we have a body to start with. And go put that back on top. Now we're going to go ahead and build the walls to the vent, but you notice that the circle, or the offset circle, is not there anymore. And what happens is when you extrude something, it hides your sketch. So you come over here to this folders on the left hand top, and you'll go to the sketch folder and open it up, and you can see that that's been hidden. So we can unhide that, and now we can see our 90 millimeter diameter circle. So now we're going to extrude that one by just hitting the extrude button and then clicking the surface we want to extrude. And then, like I said, we're going to add the 5 millimeters to the body plus the 35, which will give us 40 millimeters. So now we have what looks like a vent. We went from the sketch, and with just 2 extrusions, this is where we're at. All right, I'm going to set that back in there. Now we're going to, so our reference point, well, it moved. There it go. Is still right there for the hole. So we're going to reach up and grab the hole, and then we're just going to bring it over to the reference point and set it. And then on the right hand side, you can see that the whole menu comes up. Our diameter is already set at 7 millimeters, but the depth is set at 23, which is a little deep. So we're just going to set it for a 5.1, and that will assure that everything punches through. And then that is done. So there's our hole that we need for the first bolt to go in, and we need 3 more of those. Now this gets a little bit on the far side, and if this is your first time, you might want to go back and check out one of the other videos, maybe the one we did for the camera spacer, which was pretty quick. We did it in 15 minutes, but we're going to do some mirroring at this point. And so what we're wanting to do is create a new sketch, and that opens up our sketch palette. And what we're going to do is create lines, crosshairs, in order for it to mirror to go to the other side. Now what I'll do is just show you. So what we're going to do is I'm going to create, the line I want is a construction line. A construction line is not a true line, it's just a line that we can build upon. And so you'll be able to tell construction lines from regular lines because a construction line is a dotted line. So we've got that set. So now I'm going to hit the L button for the line, or you can go up here and just hit line. And what I'm going to do is set my first point at the top and then pull it all the way down to the next point, which is at the edge here. So there's my first construction line. And I want to build one more, so I'm going to hit enter, and then I'm going to hit L again, and then I'm going to set my horizontal line. So now we have our crosshairs, and everything I do to mirror from one side to the other will match. So I'm going to get rid of my line button. Now I'm going to mirror this area here to get that hole right there. So we hit the mirror button, and then we're going to highlight not the center, but the outside of the diameter of the hole. And then it's asking me in this mirror menu to select my next line. And the mirror line is going to be, that's what the lines we just put in is these. And so our first mirror line is going to be here. And as you can see, it's already put what will be our hole there. So we can hit OK. And then we want to do that again for the other two. So again, I hit mirror, and then I'm going to hit the diameter of the circle. I'll then select which line I want, and that does it again. I hit OK, mirror, diameter, construction line, enter. So now they're all there. So now we'll go up and we'll hit extrude, and then we'll pick our areas where we want the holes, and I hold the select button or the shift button to select each one, and it keeps them all grouped together. And then I'm going to type in, if we type in a positive number, it's going to raise that hole up, and you'll have 5 meters above it. It'll actually just make more of the plastic. So what we're going to do is put a negative number so it goes down. So negative 5.1, hit enter, and then there's all our holes. All right, and then just to be really quick about it, we're going to do a couple of fillets. A fillet will round it, or it will make the edge a little smoother on the corners. You can go as small as you want or as large. So we're going to highlight that one little corner right there, and then we're going to go up here to the fillet button, and we're going to hit that. And then that gives us this little arrow that we can actually grab and figure out where you actually want it. You can get it all the way down there or all the way back. Me, I just want to go 15 millimeters, and then that one's done, and I'm going to do the other 3 real quick. And that rounded them all off. And then I want to do one more, and I want to do this edge is where it slides into the hole, which has the vent tube that's coming from the dryer. And I'm going to do a fillet on it, but I'm only doing a 2 millimeter on it. And we are done. So let's go ahead and send that to the printer. Actually, I know there's a way of doing it a different way by turning it into a mesh, but it seems to work just fine the way I do it. I'm just going to go up to my file, and I'm going to export the file, and I'm just going to call it a vent. And it's set up for an F3D file. We're going to go down to the bottom and turn it into an STL file. And then I'm going to go ahead and export. And that is over in my downloads. So let's go over there. Okay, I appreciate you sticking around this long. Let's take a look at it. Let's nibble right off of it. That's a nice print. Yep, I'll install it and take a picture of it, and perhaps you'll get to see it. I'm so sorry for the long video today. There we go. Won't keep you very long. I appreciate you stopping in and watching my video. I don't know what I'm printing next, but I hope you're printing it with me. Thank you so much, YouTube. See ya.